Hello students, welcome to the Power Electronics. In this section, we are going to learn experiment on DC to DC converter. DC to DC converters are three types. One is buck converter, second is boost converter, third is buck boost converter. Simulation implementation on buck converter. Input DC is 10 volts, resistance value is 12.5 ohms, L is 6 millihenries, C is 5000 microfarad. This is a simulation block diagram of buck converter. Simulation implementation on boost converter. Input DC voltage 10 volts, resistance is 12.5 ohm, L is 6 millihenries, C is 5000 microfarad. Block diagram of this boost converter. Simulation implementation on buck boost converter. Input DC voltage 10 volts, R is 12.5 ohm, L is 6 millihenries, C is capacitor 5000 microfarad. This is a simulation buck boost converter. Pulse generator parameter, pulse type, time base, time, use simulation time, amplitude 1, period 1 by 1000, pulse width, here it is given 40, you can start from 20, 40, 60, 80. MATLAB 19 years simulation block and paths. So these are the blocks are required. So using this path, so select all the blocks. Now we'll do the simulation on MATLAB. Double click the MATLAB icon on desktop. Double click Simlink. In the Simlink, double click on block model. So your model is open with Untitled. For this you have to save. Go to File, Save as, EXP8, save. Your model is saved with EXP8. Now you need a block. For this, go to library browser. Go to path. First select as a Simscape. Under this electrical, specialized power system, in that fundamental blocks. In the fundamental block, select Power GI, add to your model. Next, select as a electrical sources. In that, select DC voltage source. Elements, select series RLC branch, add to model. Measurements, voltage measurement, add to model. Select current measurement, add to model. In power electronics, select as a IGBT with diode and select as a diode, add to model. Now I want to measure as a mean. In control measurement block, select mean block, add to model. Now we want to see the waveforms in the scope. For this, under Simlink, Sinks, select scope, add to model. Select display, add to model. Now we'll separate all the blocks. In series RLC branch, we need an RLC. So we have to select one more RLC branch. In first one, select as a inductance, that is L as 6 millihenries. Apply and OK. Second one, select as a branch type, select as a C capacitor, give 5000 value. Apply and OK. In third one, branch type, select as a R, resistance value is 12.5 ohms. Rotate the diode by pressing Ctrl plus R. Rotate the capacitor by pressing Ctrl plus R. You need one more current measurement. Select and place here. Resistor also Ctrl plus R, rotate. One more voltage measurement. Copy and paste. And bus pulse generator is required. Under Simulink, sources, pulse generator, add to model. Now we'll make the connections. First, double click the DC voltage source. Give as a input voltage 10 volts. From DC plus terminal to current measurement plus terminal, negative terminal to IGBT and diode collector terminal, emitter terminal to inductor, diode cathode terminal to between emitter and inductor terminal, inductor other terminal to current measurement, one terminal, capacitor one terminal to inductor other terminal, current measurement negative terminal to resistance one terminal, resistance other terminal to capacitor, diode anode terminal to capacitor terminal, and DC voltage source other terminal to diode anode terminal. Now double click the pulse generator. Now we'll change the parameter. Pulse type time base, time, use simulation time. Amplitude 1, period 1 by 5000. Pulse width 20 percentage. Phase delay 0. Apply. OK. From the pulse generator out terminal to IGBT gate terminal. Now this voltmeter will be measured DC voltage as an input voltage. From this voltmeter will be measured across the load output voltage. Now double click the scope, increase the input terminal. For this, go to configuration properties, number of input port to 4, layout 4, apply and OK. You can take one more scope. Select scope, add to model. For this will be measured across the IGBT voltage. Now input voltage to scope 1 terminal, input current second terminal, output voltage to third terminal, output current to fourth terminal. Now we can measure the mean voltage from the output voltage, connect to output voltage and connect to display. Save your model by pressing Save Model. Now reduce simulation time to 1. This is as a circuit diagram of a buck converter. Now the pulse width is given as a 20%. Now we will change the 40 pulse width, 60 and 80. Now it is as a 20%. Run the simulation by pressing Run button. Now change the inductance value. Okay, say capacitor. When it is in duties, that percentage 20%, you got a mean output voltage 1.36. Now you can observe the waveform in the scope. Double click the scope. Auto scale it. Now here this has a input. Change this scope wave name, configuration properties, input voltage, second one as a input current, apply and OK. Third is the output voltage. Output voltage and OK. Fourth is output current. Now this output voltage at duty cycle is 20%. So this waveform you have to save in the folder. Close this. Again change the duty cycle. Here pulse width as a 40%. Apply and OK. Save model. Run the simulation by pressing Run button. You can observe the mean voltage is 3.521. You can observe the output voltage. So when this output voltage at duty cycle is 40%. Save this waveform in the folder. Like here 16 pulse width. Apply and OK. Run your simulation. Now what happened? Mean voltage is 5.679. This output voltage at duty cycle is 60%. Save this waveform in the folder. Now give the pulse width as a 80%. Run the simulation. Now you can observe the waveform in the scope. When duty cycle is 80%, you got this output waveform. Save this waveform in the folder. This is and this also take a screenshot and save in the folder as a buck converter. Now we'll do as a boost converter. We'll modify the circuit to boost circuit. Now we'll design the buck boost converter. For this, go to library browser. In Power Electronics path, under Simscape, Electrical, Specialized Power System, Fundamental. In the Fundamental, select as a Power GI, add to your model. Select electrical sources. In that, select DC voltage source, add to model. Elements, select series RLC branch, add to model. Measurements, select voltage measurement, add to model. Select current measurement, add to model. Power electronics, select diode, add to model. IGBT diode, select, add to model. Control measurement, in that measurement, select as a mean, add to model. Similarly, commonly used blocks, select as a scope, add to model, or select sinks. In that also select scope and select display, add to model. Sources, select. In that select pulse generator, add to model. Now we'll separate all the blocks. Now in series RLC branch, we need an RLC separate. So for this you can copy the series RLC branch. First select as a inductor, double click this. Branch type, select as a L is 6 millihenries. Apply and OK. Second one, select as a capacitor. Branch type C 5000. Microfarads. Apply and OK. Branch type, select as a R 12.5 ohms. Apply and OK. Select pulse generator. Change the parameters. Pulse type, time base, time, amplitude 1, period 1 by 5000. Pulse width give as a 20%. Phase delay 0. Apply and OK. Now select DC voltage source. Double click. Amplitude is 10 volts. Apply and OK. Now you do one more voltage measurement. Copy. Current measurement. Copy. First make the connections. DC voltage source, positive terminal to current measurement. Current measurement, negative terminal to IGBT collector terminal. Now rotate this inductor, controller. Rotate the diode. rotate the capacitor controller, rotate the resistor, now from IGBT emitter to inductor one terminal, inductor other terminal to diode cathode terminal, diode anode terminal to capacitor, and current measurement negative terminal to anode and capacitor joining point, current measurement negative terminal to resistive load one terminal, resistive other terminal to capacitor one terminal, inductor other terminal to capacitor and resistor joining point, DC voltage source negative terminal to inductor capacitor resistor joint point. Connect this voltmeter across this DC voltage source. It measures as a input voltage, and from the pulse generator to IGBT gate terminal, take one scope to measure the IGBT voltage. Now double click the scope, increasing the number of input ports. For this, go to configuration properties, number of input port to give as a 4, layout 4, apply and OK. First connect as a input voltage, first one, current input current measurement to second port. Now this voltmeter connected across the load, that will be measured output voltage, give as a third one, output current to fourth port. Now you can measure the mean output voltage connected to voltage measurement output terminal. Save your buck boost converter by pressing save button. And run the simulation by pressing run button. Now you can observe the mean it is coming is negative. So now when duty cycle is 20%, you got an output voltage. Now you can label this all the waveforms, configuration properties, input voltage, configuration, input current, output voltage, output current, output current. Okay, now we'll check one more time. You can replace this capacitor to, we'll place the reverse. Again run your simulation by pressing save your model. Run your simulation by pressing run button. So can place the capacitor as this. We'll change the resistance. Again run your simulation by pressing run button. Okay, don't change any reverse of the any component. So we got a negative. Like that you can take the values. Now when duty cycle is 20%, you got a mean voltage is this much. Now change it to pulse width to 40%. Apply and OK. Save your model. Run your simulation by pressing run button. Minus 5.866 mean voltage. Now these are output voltage. Save this waveform in the folder when duty cycle is 40% or pulse width is 40%. Now pulse width change to 60%. Run your simulation. This voltage, output voltage at pulse width is 60%. Save this waveform in the folder. Next, change it to pulse width is 80%. Run your simulation by pressing run button. Now output voltage at pulse width is 80%. Save the waveform in the folder. Now this circuit diagram also you have to save. These waveforms should be saved in the folder. Results of buck boost and buck boost. Now we already saved all the circuit diagrams, and for different duty cycles we already saved the files. Now the saved files here you have attach the circuit diagram of buck boost converter with R load in MATLAB Simulink. Attach the buck simulated waveform at 40% duty cycle, source voltage and current, output voltage, output current and voltage across the IGBT also. Third is attach the circuit diagram of boost converter with R load in MATLAB Simulink. Attach the boost simulated waveform at 40% duty cycle. Fifth is attach the circuit diagram of buck boost converter with RL load. Attach the buck boost simulated waveform at 40% duty cycle. Observations of buck boost and buck boost. Now when you are giving different input voltage, different duty cycles of each runs, and these are the calculated values and simulated output values. Here you have to place it for buck boost and buck boost. Thank you.